Hello and welcome to the Swine Disease Reporting System. This is report 29 of July 7th, 2020. My name is Daniel Linhares with Iowa State University.
Hello, my name is Giovanni Trevis. I'm with Iowa State.
And so, Giovanni, we've come a long way since the first report. New pathogens, new labs, new algorithms, new ways to describe the patterns of pathogen detection, meaning that if we know how the pathogens behave in terms of detection over time, that means we can also start predicting and describing the change in the forecasts, sharing with the swine industry whenever there are signals of changes in those patterns, right?
That's correct, and we have been getting a good learning experience with this project and trying to provide the best information that we can to the U.S. swine industry.
And so we thought that in this report, we will go a little bit deeper. We'll go behind the scenes and share with the audience more about a bit about the background of the swine disease reporting system and talk a little bit deeper about the graphs, the algorithms, and everything that the report brings you on a monthly basis in the static report, and on weekly and sometimes, depending on the dashboards, daily basis patterns of pathogen and disease detection in the industry. And so the first question, Giovanni, is what is the swine disease reporting system?
That's a good question. The swine disease reporting system is an initiative that has multiple projects to aggregate data from participant veterinary diagnostic laboratories and report to the U.S. swine industry. The participant VDLs are the Iowa State University, University of Minnesota, South Dakota State University, and Kansas State University, respective veterinary diagnostic laboratory. This project reports the major findings of agent detection and is funded by the Swine Health Information Center and some minor funds from the American Association of Swine Veterinarians Foundation and the Iowa Pork Producer Association. It generates monthly reports, and additionally to the static monthly reports, we have online dashboards that contains simple and or sophisticated dashboards to report the project generated information.
And what is the goal of the SDRS program?
The goal is pretty simple, is to share information on endemic and emerging diseases affecting the swine population side of the United States, to assist veterinarians and producers in making informed decisions on swine disease prevention, detection, and management.
And you talked about Iowa State, Minnesota, South Dakota, and Kansas State VDLs, and who else are the project contributors?
Oh, from these VDLs, we have 24 collaborators, but additional to that, we have a fantastic group of collaborators that we call advisory group, and this is composed by 11 field veterinarians and producers that provide inputs to the report. The way that they do, we issue a preliminary report in the middle of the month, run to these collaborators, and they give some contributions, and the major monthly finds and interpretation that this advisory group reports back to us is incorporated in the PDF report that is released on every first Tuesday of the month. All collaborators and the advisory group names are listed in the first page of the PDF report.
And that first page has some of this background that we just talked about, right?
There is links in the first page for each university and for the channels where we distribute the information.
Great. And in the second page, you talk about the detection of first virus RNA over time by PCR, right? So can you explain the information is reported in those 6 charts there?
Sure. The first chart It's a column bar chart that is organized by year and month, and it presents the number of submissions. Here, they are defined as cases. Those are tested for PRRS virus, RNA by RT-qPCR. And we report this according to the categorical results of this case as positive, negative, suspect, or inconclusive. And to facilitate the visual interpretation in terms of the total number of cases tested by year and month, we added a trend line to inform this variation during the year in the number of the cases tested.
All right, and you, as part of your PhD, developed several ways to monitor this data. How can you talk a little bit specifically about PRRS here, how you monitor all this data that is reported in these charts, in those charts?
Yes, if we compile the data from the VDLs and leave like that, it's just a stat data and doesn't provide too much information about is that changing in the way that is detected or not. So we developed a statistical model to scan the percentage of positive results using weekly data. The way that it works, we took the previous 3 years of historical data. So for 2020, we took the years of 2017, 2018, and 2019, and used these 3 years weekly information as the baseline to construct a model. And based on these 3 years of baseline, we forecast the next year weekly expected detection. For each week of the 2020, we added a 95% confidence interval to these predicted results. So when the observed detection during 2020 is above or below the 95% confidence boundaries, it pinpoints that there is some changes in the pattern of detection. When we see these changes in the pattern of detection, this is indicative that may deserve some further investigation. And this information is reported in we call a cyclic regression model, and is reported on the PRRS virus charts.
Right, so if I understand right, the changes in pattern detection are considered when detection crosses the upper or lower boundaries, right?
Yes, that's correct, and this is a great question. If it's above the boundaries, it's very straightforward. This indicates that detection for the monitor agent has been increased and probably is associated with higher activity of this agent in the field. If the detection is below the boundaries, this may indicate a decrease in detection of the monitor agent, and here the interpretation may raise some insightful observations. The first, it's pretty straightforward. It may indicate that we are doing a great job controlling and eliminating the agent in the field, and as a result, we are seeing less detection of the agent. We saw this pattern in the beginning of 2018, when PRRS detection was in the lower boundaries for the 95% predicted values. Second option is that new strains of the agent may have emerged, and the current testing techniques in place needs to be refined to detect those strains. And the third and undesirable one is that if we are seeing less detection, this may indicate that a new emerging epidemic agent has entered in the herd.
Okay, right. You talk about epidemic agent. Can you elaborate a bit more on using this model to monitor epidemic agents?
Yes, it's a model, and the information can generate insights. And the way that it works is in a scenario where an epidemic agent is introduced into a naive population, the most reasonable approach is to collect samples and submit for testing for those agents that we know that are present in the population, and have a clinical presentation similar to a new epidemic agent. As more animals get infected, the need for testing requesting may increase. And with this increase in testing, we are going to get negative results for the already endemic agent. So I'm moving out of PRRS right now and taking back to the 2013, when the pattern of detection of endemic agent that was named as transmissive gastroenteritis virus did change considerably in the second half of the 2013 with a very low detection. The number of submissions that was tested for these agents more than double. So this could indicate that a new agent could be inside of the U.S. swine population at that period of time. We know that PD was already here, but we didn't know that Delta coronavirus was here. And there is some other studies that pinpoint detection of Delta coronavirus using tissues that was stored in VDLs back in the middle of 2013.
Yeah, cool. So when you were monitoring for an agent, you were actually monitoring for that one as well as for that syndrome in general, right? So if you see spikes in respiratory cases and it's not PRRS, well, take a deeper look. It can be something else causing respiratory syndrome, and you just provided the example of that happening with the enteric agent. All right, but let's return here to the PRRS page. So the swine production system is organized in different production phases. And so you have a chart here to describe PRRS detection by age category. Can you talk a little bit more about what is the age category here in those charts?
Yeah, the age category is trying to represent the farm type where the samples were collected. And we have a column bar chart that presents the proportion of cases that was tested for PRRS virus by age category, by year and season. So this gives a great overview of approximately 4% of the cases tested for PRRS virus are coming from adult sow farms, 30% from winter market animals, and the remaining are the cases that we were unable to identify where those samples were collected. The second chart, it's a line chart that presents the percentage of positive submissions according to age category by year and month. This helps to understand where change in percentage of positivity came from.
All right, and taking a look at the whole page, what are the highlights for the PRRS detection for June of this year, 2020?
Well, the first positive case in June was 25.34%. That decreased from the 27.55% in May. So increased detection in winter market animals was observed in the first 3 weeks of the month, and this week increased detection was in the upper boundaries for the cyclic model for this period of the year.
All right, and what did you hear from the advisory group regarding PRRS detection this month?
Well, the advisory group pointed out that the increased detection is very likely to be associated with downstream detection in piglets that they are coming from farms that broke with PRRS early this past winter. There was some undesired commingling strategies that may have facilitated the winter market cross-contamination. And taking this in consideration, the advisory group reminded us that there is a need for continued education and remind of farm personnel to comply with biosecurity and biocontainment practices, especially in terms of the farm entry, people, animal, and feed movements to contain the spread of these agents across farms.
Yeah, great thoughts, great comments. And so, a little bit deeper here in the PRRS section, Giovanni, last month, there was new information introduced here where you had in the bonus page the ability to monitor agent detection at the state level. And now in July, you had a statement saying that the percentage of PRRS positive cases was above 3 standard deviations from state-specific baseline in Minnesota, South Dakota, and Indiana, right? So what is that information referring to? Can you elaborate a little bit more for us?
Yeah, sure. So we start to monitor first virus detection at a state level. The way that we work, we use historical data that was developed for a state-specific baselines for the percentage of positive cases. We do not compare across states. The baseline is a state-specific. So each state has a specific baseline that was constructed based on 3, 4, or 5 years of historical data. This data was scanned by 21 different smoothing models that accounting for trend and seasonality in the data. So the best model that we found is used to forecast that come year monthly expected detection. For this monitoring algorithm, we added a new exponential weighted moving average model that scanned the difference between the forecast expected detection and the observed detection. So we reported changes in terms of standard deviation from the baseline, and the way that we consider these changes are 2 standard deviations from the baseline above or below are expected. So we call this within the baseline. Change between 2 and 3 standard deviations from the baseline signals that something may be changing the detection of this state-specific baseline. When we observe change greater than 3 standard deviations, this may indicate that changes from the baseline were detected and deserve further investigation. So the results of all of these monitoring models are displayed currently in an interactive color map dashboards that are available on the SDRS webpage. Here in the report, we just provide information of the most relevant changes in terms of agent detection encountered in this state specific baseline. So the information that we see from Minnesota, South Dakota, and Indiana are based on these statistical models that pinpoint out that the detection was above expected for these 3 states.
Yeah, so really good ability for the industry to visualize here not only what's going on in the whole industry level, but at their specific states, and where we know that there are distinct patterns of pathogen detection between different states, right? So that's good. And you said that the online version is updated. What's the frequency that you update that? And is that available for anyone, or is there any password? How do people access that?
That is available on the Swine disease reporting system webpage. The first page of the PDF report has the link to this webpage, and these are freely accessed for anyone that wants to take a look and compare the detections. And as this is monthly data, we update every beginning of the month with the information of the past month.
All right. So moving on, still in the first page here, last question. Can you talk about the charts informing RFLP detection?
Yep. So this is a pilot project from our state university. We are looking to incorporate other VDLs information to that. So we report the RFLP detection over time, and we understand that RFLP has some limitations to inform genetic variability of the first virus strains, but they can still be used to provide interesting insights into the changes of detection over time. If we look for the charts, we can clearly see that 5 RFLP types, the 252, 174, 184, 132, and 144, are the most frequent detected. And we can identify trends like the 184 has been the most frequently detected during 2020. If we look for the 184, it has been started detecting the United States population early in 2000, and it has been frequently detected until up to 2006, 2017, when this RFLP type reached the lowest levels of detection using iostate data only, and then this RFLP type 2 started to re-emerge again. We cannot forget that this is a wild type strain, but most recently that was the introduction of a first MLV vaccine that has this RFLP type in its composition and has some contribution for the big change in 2020 detection.
All right, and every now and then you add a bonus page diving deeper into the RFLPs to that. All right, that was a lot of information here about the swine disease reporting system and the PERS and the charts, right? And moving forward here to the enteric coronavirus detections, including PD, Delta, and TGE. A lot of those charts are the same, so we don't have to go into the details of the chart. We can jump into the conclusions of the findings. And so, what are the highlights here for the enteric coronavirus section, Giovanni?
A decreased detection of PD and Delta coronavirus positive submissions was observed from May to June. The detection of both agents was within the expected boundaries for this time of the year, and PD percentage of positive submission was below or within the baseline for all the 11 monitored state-specific baselines, and was observed some detection of both expected for Delta coronavirus in North Carolina.
And what did you hear from the advisory group on this?
Well, the advisory group was very consistent in reporting that this decreased detection in June is aligned with the summer expected seasonal decrease in detection for these enteric coronavirus agents, and some economical contingents amid to coronavirus COVID-19 may have contributed for lowering some testing strategy at some specific farms and states that has been potential had some contribution here.
I see. All right, and so moving on to the Mycoplasma pneumonia page, what do you have to say here?
Well, the detection of Mycoplasma pneumonia is within the expected for this period of the years, and we don't have any specific highlights beyond that. Okay,
and moving to the last page of the report, which is disease diagnosis report. And so what is the information? Can you talk about this page and where did you get this information from?
Yeah, the previous pages we just talked about detection by RT-PCR, and here we are talking specific about disease diagnosis. So to confirm a particular pathogen as a cause of a disease process that requires diagnostic investigation of information and finds, which include clinical presentation, submission, and story details, test results, and compatible microscopic or both lesions by a capable diagnostician. So this information is a pilot project from Ohio State University VDL, and when the ISU VDL diagnosticians conclude the investigation, they assign a diagnostic code to each case, which is recorded on the laboratory information management system, and this information was the one that we used to create this report. The report just presents the 10 most frequent diagnoses and their diagnosis combination at a submission level for the respiratory, enteric, and neurological system.
Yeah, right. And so in the report, there's a sentence where you say that there was no significant increase in the diagnosis of any pathogen or disease syndrome. What is this information referring to?
Well, when you have a lot of this information about disease diagnosis, it's impossible to go one by one and scan, look for that, and try to identify some change. So we developed a statistical model that scan weekly number of cases for each agent and system. We use the previous 7 weeks as a moving average baseline. So every time that we observe the number of diagnoses that exceed 3 standard deviation from the slide baseline mean value, the algorithm pinpoints a signal. So these we run basically 29 weekly charts, and for easy interpretation of the readers, we just insert here in the PDF report a sentence that describes the change that was observed from the period that they are reported information in these PDF charts.
Mm-hmm. So you said that you run 29 different algorithms, right? 29 different analysis, and that includes analysis to verify if there's any spike in either disease syndrome or pathogen as a specific pathogen, right?
Yeah, that's a great point. That's correct.
Okay. All right. The final question now, Giovanni, the who cares question. So what can all this information that you just presented here during our conversation, who uses that? How can people use that? What are the implications for and applications for this data?
Well, this data is aligned with our goal to share information for the U.S. swine industry, and this platform allowed to share the data in a consistent structure and accurate and useful format. The ability to monitor these veterinary diagnostic laboratory submissions information provides useful animal health data that is continually updated to the industry. This seems to be a unique project that uses VDLs data and has the ability to be updating every single month. Basically, this project allows to acquire new knowledge on mega trends of detection for the monitor agents, helps to understand the seasonal effects of agents detection. For example, increased detection of percentage of positive cases during colder months for PRRS virus and enteric coronavirus was one of the highlights that we observed with this data. This provides an aggregate database that can be used for benchmark with the production system-specific information in terms of agent and disease diagnosis. We have now constructed the ability to scan this database by different algorithms and inform. This is informative to understand the change in terms of overall detection and or at a state level information, and for disease diagnosis at agent level information. This may be useful to reinforce biosecurity and biocontainment compliance to reduce the spread of the agent across farms when you pinpoint some signals. And this project brings a monthly report with the highlights of all of this data that is compiled and aggregated. Additionally to that, we have this online web page where we have the online dashboards that brings more ability to filter and slash the data over time by age category, by specimen, according with the question that the reader wants to make the question. It's available and you can do that, and it's free to access that.
All right, so sounds like a powerful tool to surveil the United States swine herd for endemic and, as you say, also emerging pathogens and disease syndromes at the national or at the state levels, right? So very good, a lot of information. It was packed. This podcast was packed with a lot of information about the swine disease reporting system and the analysis, the algorithms that Giovanni developed, and it has been fun. It has been a great ride. And with that, looking forward for the report 30 coming up next month. Thank you.
Thank you.
Thank you.